Welcome. We're going to look into some material you sent over, focusing on, well, a pretty significant shift happening in the utility sector.
That's right. We're focusing on how artificial intelligence isn't just theory anymore. It's actually becoming a core tool for managing our power grids, keeping things running.
And changing how energy moves around, how you interact with your provider.
Exactly.
So our aim today is to sort of unpack this material, pull out the key ideas. We want to get a handle on where utilities stand now, what AI means for them, and for you, the difficulties they face bringing it in, and crucially, what needs to be there for AI to work well here.
And one thing that jumped out right away from your sources is just how many companies are already working with AI.
Yeah, that was surprising. What was the number again?
Well, the IBM study mentioned suggests 74% of energy and utility firms are already putting AI into practice or at least exploring it seriously. So this isn't some far-off thing. It's happening right now.
Okay, so let's talk about why. Why are utilities suddenly so interested in AI? What are the big pressures pushing them, according to this material?
Well, there are a few major drivers. A big one is just the physical stuff, the poles, the wires, substations. A lot of it is old, built decades ago.
Right, aging infrastructure. Needs a lot of upkeep.
A lot of upkeep and upgrades too. Then you have regulations. Utilities are under more scrutiny than ever. Reliability, safety, environmental targets are getting stricter.
And the energy sources themselves are changing. It's not just big power plants sending energy one way anymore, is it?
Not at all. That's a huge shift. You've got distributed energy rooftop solar panels, wind farms, batteries popping up everywhere. They feed power back into the grid.
Makes it flow in multiple directions.
Exactly. Much more variable, way more complex to manage than the old, simple model.
And then there's us, the customers. Our expectations are changing too, right?
Absolutely. People want things to just work reliably. They want more information about their energy use, faster answers when they call, just more transparency from their provider.
So all these things together, old gear, rules, new energy sources, demanding customers. It makes the old ways of operating tough.
That's pretty much it. The complexity is just getting beyond what traditional methods and even human operators alone can easily handle.
And that's where AI comes in, moving from just an idea to something they really need strategically.
That seems to be the main point in the sources, yes. AI can process just vast amounts of information, the kind a modern grid throws off constantly. It can spot patterns, predict problems in ways that are, frankly, impossible to do manually at that scale and speed.
So it's like an intelligence layer, helping manage all this new complexity.
A necessary one, increasingly.
Okay, so where is this AI actually being used today? What examples did the sources give?
Several key areas. One is monitoring the grid in real time. Think sensors everywhere, sending back data constantly. AI systems watch that data stream.
Looking for trouble.
Basically, yeah. Looking for tiny anomalies that might signal a problem brewing before it actually causes an outage. It's about getting ahead of failures.
So moving from reactive fixing to proactive prevention.
That's the goal. Another big one is predicting equipment failure. AI looks at an asset's history, its current sensor readings, temperature, vibration, things like that.
And figures out if it's likely to break soon.
Exactly. It calculates the probability of failure for, say, a specific transformer or circuit breaker. That lets the utility schedule maintenance proactively during planned downtime. Much better than emergency repairs after it fails.
Makes sense. What about forecasting energy demand? That sounds trickier now with solar and wind fluctuating.
It is much trickier, and AI really helps here. Old forecasts might just look at past usage and basic weather. AI models pull in way more data, really detailed weather forecasts, economic activity, even local events, plus fine-grained usage patterns.
So they get a much more accurate prediction.
Much more accurate. That precision helps utilities generate the right amount of power, manage the grid flow better, and cut down on waste.
Is AI helping with the business side too, like office tasks or sending crews out?
Yes, definitely. Automating routine customer service interactions, parts of the billing process. And optimizing field crews is a big one mentioned. After a storm, for example.
Oh, right. Getting power back on faster.
Yeah. AI can analyze all the outage reports, figure out where the damage is, group the jobs logically, and calculate the most efficient routes for the repair teams. It helps speed up restoration significantly.
And for the managers, especially during a big event, how does AI help them decide what to do?
In a crisis, there's just a flood of information. AI can process all that real-time data network status, crew locations, equipment availability, and give managers clear insights on where to send resources for the biggest impact.
Helping them make better calls under pressure.
Precisely. And it's not just for crises. For long-term planning, AI analytics help executives see trends, model different scenarios, and make smarter investment choices based on data, not just gut feelings.
The sources mentioned something about utilities having lots of data but not enough insight.
Yeah, that's a common theme. Data-rich, insight-poor, AI helps bridge that gap. And the sources point out that integrated systems providing these insights can cut operational costs quite a bit. They mentioned a figure around 23%.
Okay, so that's what's happening now. What about the future? What's the vision presented in the sources for where AI takes utilities next?
The vision is pretty ambitious. They talk about grids that could become somewhat autonomous, self-healing, essentially.
Self-healing grids, what does that mean?
It means an AI system could detect a fault, like a tree falling on a line, and instantly reroute power around the problem or isolate that section, all in milliseconds, potentially preventing a wider blackout without direct human command for every step.
Wow, that's a big step.
It is. It's the direction things are headed. AI is also seen as absolutely vital for managing even more renewables smoothly. Imagine AI predicting solar and wind output with incredible accuracy.
So it can coordinate them better with battery storage and traditional power plants.
Exactly. Keeping the grid stable even when large parts of the supply are variable. It requires constant, complex balancing.
And AI could predict problems on the grid itself, like traffic jams for electricity.
Sort of, yeah. Predicting grid conditions in real time, using current usage, weather, maybe even traffic patterns or big events happening, AI could foresee torrential congestion or demand spikes before they happen.
Allowing utilities to adjust things proactively.
Right. Keep the system balanced, efficient, and prevent issues.
How about energy efficiency? Can AI help us use less power overall?
It can help on both ends. It can analyze the whole system to find energy losses, maybe in transmission or inefficient equipment. And for customers, it could analyze your specific usage.
And give me personalized tips.
Yeah, tailored advice on saving energy, or maybe suggest a rate plan that actually fits how you use power better. Good for your bill, good for the utility, good for the environment.
What about the people working at the utilities? Does AI replace them?
The vision presented isn't really about replacement. It's more about augmentation, giving workers better tools. Think field techs using augmented reality glasses, getting AI guidance during a repair.
Or planners using AI to optimize schedules?
Exactly. Automating the routine stuff frees up skilled workers to focus on the more complex problems, or strategic thinking, or customer interaction.
And with extreme weather seemingly on the rise, can AI help make the grid tougher, more resilient?
That's a major focus area. AI models can simulate the impact of, say, a hurricane or a wildfire on specific grid components.
So they can see which parts are most vulnerable.
Right. By predicting the storm's path and intensity, AI can pinpoint vulnerable substations or lines. Utilities can then take action before the storm hits, maybe reinforce things, or pre-position repair crews nearby.
Minimizing damage and speeding up recovery.
That's the idea. Make the grid better able to withstand and bounce back from these events.
Okay, so AI impacts the grid, the operations. What about my direct interactions as a customer?
That's changing too. AI enables much more personalized service, based on your data, not just generic assumptions.
Like tailored energy-saving tips we mentioned.
Yes, or suggesting specific rate plans, maybe sending alerts relevant only to your service area. It makes the utility feel more responsive to you as an individual.
And customer support. Waiting on hold is never fun.
AI is improving that. Chatbots, automated voice systems, they can handle common questions instantly, 204/7. That frees up the human agents for the really complex or sensitive issues. Should mean faster answers overall.
And during an outage, which is when you really need info.
AI helps utilities be more proactive. Instead of waiting for calls, they can use AI to identify affected areas faster and automatically push out alerts, maybe via text or an app.
With specific details like estimated restoration times.
Ideally, yes. Managing expectations is key during an outage. Clear, timely information helps a lot.
This all sounds very promising, but putting AI into these huge, complex utility systems, it can't be simple. What are the big roadblocks the sources mention?
No, it's definitely not simple. There are major challenges. A huge one is just integrating new AI tools with the old systems utilities often rely on.
Legacy systems.
Exactly. Old IT systems, operational technology that wasn't designed to talk to each other easily. Data gets stuck in silos, finance data here, asset data there, customer data somewhere else.
And AI needs all that data together.
It works best when it has a complete, consistent picture. Getting data out of those silos, cleaning it up, making sure it's accurate and reliable, that's a massive technical and often expensive undertaking.
And if the data isn't good, the AI's insights won't be good either.
Garbage in, garbage out, basically.
Mhm.
So data quality and governance are critical, plus cybersecurity. As you connect more systems, you create more potential entry points for attack. Protecting the grid, protecting customer data is absolutely paramount.
What about the people? The workforce?
That's another big piece. Utilities need people with new skills, data scientists, AI specialists. But it's also about change management for the existing workforce.
Helping them adapt to new tools, new ways of working?
Yes. Getting comfortable relying on data-driven insights, using AI-powered tools. It requires training, communication, and building a culture that's open to these changes.
Okay, so we have the pressures pushing for change, the potential of AI, and these significant challenges. The sources seem to really stress that for AI to work, you need a solid foundation. They talk about integrated systems, like ERPs.
Yeah.
Why is that base layer so important?
Well, the core idea is that an AI insight is kind of useless if you can't act on it effectively across the business. We talked about data silos in legacy systems.
Right, information trapped in different departments.
An integrated system, like a modern enterprise resource planning system, breaks down those walls. It brings data from finance, assets, maintenance, supply chain, HR, all onto a single connected platform.
So the AI sees everything in context.
Precisely. It's not just an alert saying sensor X is high. It's sensor X on this specific transformer, which had this maintenance history, requires these parts which aren't in stock, the nearest qualified crew is here, and the cost of failure is estimated at this much.
Ah, okay. So the AI's prediction can trigger real actions because all the pieces are connected.
Exactly. That holistic view allows an AI alert, maybe predicting an equipment failure, to automatically kick off the right business processes. Order the part, schedule the crew, update the maintenance log. It connects the insight to the action.
Making the whole operation smoother and more efficient.
That's the key. A unified system gives you that visibility, asset status, crew locations, inventory, financials, all in one place. It provides the context needed to act quickly on AI recommendations. The sources emphasize this connected data environment is what makes AI scalable and valuable across the utility.
And adaptable for the future, too.
Yeah, they mention that having a flexible, integrated system, the sources mention IFS ERP as an example, helps ensure that the technology foundation you build today can support new AI capabilities as they come along tomorrow.
And the sources also note companies like Astra that help utilities put these foundational systems in place.
That's right. Building that unified data foundation is complex work. Firms like Astra specialize in guiding utilities through that process, setting up the systems, and making sure the data is ready to actually fuel effective AI initiatives.
So to wrap it up, AI clearly offers huge benefits for utilities. A more reliable, efficient grid, better customer service, smoother integration of renewables, but actually getting those benefits really hinges on having a solid, connected data foundation underneath.
A unified system that eliminates those data silos and lets AI insights flow directly into operations and decisions.
That seems to be the crucial takeaway. AI provides the smarts, but the connected system provides the nervous system to make those smarts useful.
Well put.
It does make you think differently about flipping a light switch.
Yeah.
And pondering that idea of self-healing grids, it goes beyond just the tech, doesn't it? If the grid itself becomes that smart, how does that change the jobs of the people who've always kept it running? Or even how we fundamentally view something as basic as energy delivery?
It definitely opens up some big questions about the future of work in this industry and maybe even our relationship with the critical infrastructure we depend on every day.
Food for thought. Thanks again for sending over the source material that let us explore this.